Alright, here we go. We'll put this up online just in case you need to look at it. Number 6. It's the square root of x over 9 minus the square root of x. Okay, we got to simplify this, and it says rationalize the denominator, right? So we have to get rid of the square root in the denominator. So we have to get rid of this thing. How do we get rid of it if it's a if you got a minus in between here like this? 9 plus square root of x. Do that to the bottom, what? Do it to the top too, right? Everybody with me on that? Okay. It's called multiplying by its what? What's the word? Conjugate. All right, so let's do the bottom first. I always like to do that because that's actually a little easier, to tell you the truth. Because when I multiply by the conjugate, the outside and the inside add up to 0. So I don't even have to bother multiplying those together and adding them up, do I? Because I know it's going to be a 0. So all I got to do is just the first and the last and put it right here. So 9 times 9 is 81. Okay, a negative times a positive is negative, and then the square root of x times the square root of x is x. Boom, there's your bottom right there. Okay, now we got to do the top. Now I put this in parentheses for a reason, because this x, the square root of x, has to be multiplied by both of these things, not just by the 9, not just by the square root of x. It's got to be distributed through. All right, so let's multiply those together. Well, this is just a whole number, and this is a square root, so the only way I can multiply those together is if I just write 9 square root of x. Okay, it's not the square root of 9x. You understand? Okay, it's a 9 on the outside, and it's times the square root of x. And then I put a plus, then I multiplied this times this. Well, we just did that already. What's the square root of x times the square root of x? Just plain old x. And that's it. That's all there is to it. Okay, nothing can cancel, right? That doesn't cancel with this because this is being added to something else. You can't add those two together because they're not like terms. That's a square root of x, and that's just a regular x. 9 doesn't go into 81. You can't do that because, again, this 81 is part of a subtraction right here. So nothing cancels out. You just leave it like that. That's all you can do with it. Okay? What else? 8 from this lesson? Okay. So it's the square root of 7 over 5. Now we're rationalizing the numerator this time, it says. Okay? Normally, most math books I've seen always have you rationalize the denominator. If they said to simplify this, then you would rationalize the denominator, which means you would get the square root out of the denominator. But this specifically says rationalize the numerator, so we've got to get the square root out of the numerator. So first thing we do is we rewrite this. If you go back to the beginning when we first started doing these radicals, you would have seen almost a problem exactly like this. The numbers might have been different, might have been 2 over 3 or something like that, but we showed you exactly how to do it. So it would be square root of 7 over the square root of 5. That was one of our rules for square roots. We went over it pretty plain. Look back on the lesson on YouTube to find it. Now, we don't want to write it like this because it says rationalize the numerator, not the denominator. So that means I have to get rid of the square root in the numerator. And I do that just by multiplying it by itself. Taking a square root and multiplying it by itself gets rid of that square root. Now if I do that to the bottom, I also have to do that, or sorry, if I do that to the top, I also have to do that to the bottom. Because what am I really multiplying by? Just like I didn't ask you that question up here. I'm multiplying by 1, so I'm not really changing the value of that. What I'm doing is I'm multiplying it by something that gets rid of that square root. That's really the only reason I'm doing that. Okay, square root of 7 times square root of 7 is just plain old 7. Multiply the bottom. Square root of 5 times square root of 7 is square root of 35. And you leave it like that. Now it looks odd. It kind of bugs me a little bit to even leave it like that because I'm so used to getting rid of the square root in the denominator. But that's what this problem says to do. This problem says to rationalize the numerator, get rid of the square root in the top. Okay? Number 7. Oh, that looks like a doozy. P plus Q. hate when they use Q. Don't they just use X and Y or A and B or something easy? Yeah, P's alright, I guess, but Q.
Well, when you have
Anyway.
like 9s thrown in.
Yeah, exactly. Yeah, that's true. Yeah. Anyway, we'll use it. That's what they use. So let's see. It's kind of like this one right here. Kind of like the beginning of it, isn't it? You see how we got rid of the square root and this we had to multiply by the conjugate? We're going to do the same thing here. All right. So let's figure out what the conjugate is. Well, it's a plus in between these two, right? So it's going to be what? 8. Talk to me. Minus, right, square root of p plus q. All right. And then I do the same thing to the top. I'm going to put them in parentheses because it is a sum, right? It's two things. Now when I say sum, some people say, yeah, but sum, I thought sum was the answer to an addition problem. But subtraction basically is addition, isn't it? You're just adding the opposite. So when I say sum, that kind of covers both of them, the plus and the minus, all right? So anyway, that's why I put parentheses around here. I always like to do the bottom one first. I think that's actually a little bit easier. Remember, the outside and the inside you don't have to worry about, do you? When you multiply by a conjugate. All you got to do is the first and the last. So watch how easy this is. 8 times 8 is 64. A positive times a negative is negative. And look, the square root of p plus q times the square root of p plus q. Just p plus q. That's right. Now, you got to understand this, though. It's not just minus p plus q. You're subtracting that whole thing. Do you see that? That's why on the answer it said 64. What did it say? Minus p minus q, didn't it? Do you understand why there was minus both of them? Because you're subtracting that whole sum right there. You're distributing the negative through. We'll do that in a second. Does that make sense? You what? You don't get it? Because you're subtracting not p and then adding a q, right? Because if I just put a minus in front of p plus q without a parentheses, that just means minus p plus q. What am I subtracting? I'm subtracting everything inside the square root. You follow me? So if I subtract everything inside the square root, I got to put that in parentheses. If you distribute a negative, right, then you get negative p minus q. Make sense? We'll save that for the next step, though. All right, now what about the top? We're going to have to take that 4p and distribute it through this. That's why it's important to put those parentheses there. You see? So let's multiply those together. 4p times 8. Well, 8 4s are 32p, right? Minus, now we take 4p and multiply it by this. Well, really the only thing you can do is this. 4p what am I doing? I lost track of where I was. P plus Q. That's basically the answer, right? Except they put minus P minus Q. Is that how they wrote it? Yep. Yep, exactly like that. So, tell you what, I'll just do it like this. Get rid of that. There you go. Okay. A little magic. And there's your answer right there. I mean, that looks like an ugly answer, doesn't it? And it is. I mean, it's kind of ugly, but it really wasn't that hard. It wasn't any different. Yeah, it wasn't any different than this. It really wasn't. The only thing a little bit difficult was maybe to remember to, what's the word? Distribute the negative through this P plus Q. All right, that part got maybe a little bit tricky. Maybe you didn't realize that you had to do that, but that is important that you do that. All right? Getting any better at these? Ready for the quiz tomorrow on this stuff? Should be. Yeah, go ahead. Which one? Number 2 on this one? Okay. So it's negative 5. Tell you what. Let's start at the top because this might take a little bit more room. Number 2. Negative 5 over cube root of 3 plus 32 over cube root of 24 minus 1 over cube root of 81. Alright, we did one just like this yesterday, didn't we? So what was the first thing that we did yesterday? Well, we don't find a common denominator quite yet. You got to break them down. That's right. Yep, let's take this and simplify that thing as much as we can, and let's take this and simplify that. Because eventually I'm going to have to find a common denominator, right? And there's no way I can really find a common denominator the way it's written right now. Alright, so what I'm going to do is try to simplify that and simplify that and see what we get. There's nothing to simplify here, so I'm just going to keep it the same. Don't let me forget that cubed. Okay. Plus. Now, I'm going to do this off to the side. Is that alright? Cube root of 24. Now, what do I do for cube root? I take it and I break it down into its primes. Right? So, break down 24. What do you got? 8 times 3, right? So 8 is 2 times 2 times 2 times 3. We good with that? We did this exact number yesterday, didn't we? So what do? You group them by 3s. If you're going to take the cube root, you group them by 3s. If it was a 4th root, you group them by 4s. If it was a square root, you group them into 2s. Okay, you got it? So what is this? This is 2 cubed. It's the cube root of 2 cubed. How does this simplify? It goes out front to be a what? Just a 2. Now what do we have left? We have the cube root of 3. Alright, so that's what this denominator is going to be. That's what this is right here. So it's 32 over the cube root, 2 cube root of 3. We good? Okay. Stop me if you don't understand. Let's do this off to the side too, just because it's just too much ugliness under, if you did it in the denominator. So I just do this off to the side. The cube root of 81. It's not the square root, it's the cube root. So we break it down into its primes. 9 times 9 is 81, right? So 3 times 3 is 9, and then another 3 times 3 is 9. Would you agree that's 81? Yes. So now it's cube root, so we group them by 3s. So what's the cube root of 3 times 3 times 3, or 3 cubed? It's just 3, right? Cube root of 3. And that's what this is. 3 cube root of 3. Lots of 3's flying around, aren't there? But you got to keep straight of what's going on. All 3 of these 3's are different, right? This 3 is being multiplied by everything. This little 3 is a cube root, and this 3 is inside the cube root. All right? So now, look what we have. What's my coefficient to this one right here? It's a 1. So I got a 1, a 2, and a 3. What if I had a fraction with only 1, 2, and 3? What would your common denominator be? It would just be 6, wouldn't it? Okay, so it would be 6. But this is not just a 6. What do we got attached to it? The cube root of 3. So that's your common denominator. It's not that hard, is it? It's like going back to elementary school with a 1, 2, and a 3 and finding a common denominator with that. You just multiply them together, that's 6. But you got this tagged along with it, so it's 6 cube root of 3. Now, what do? We say, what did we do to this number to get to this? What did we multiply it by? 6. So what do you do up here? Multiply that by 6, and you get negative 30. Good. Plus, what do we do to this thing to get to this? By 3. So you multiply that by 3. What's that? 96. Then what do we put a minus? What do we do to this thing to get to this? Multiplied it by 2. So you multiply that by 2. We good? Alright, so let's see. 96 minus 2 is 94. 94 minus 30 is 64. Did I do the math right? I believe I did. Over 6 cube root of 3. Before I even mess with the cube root, I could probably, something will cancel out here with this, wouldn't it? Okay, yeah, 2 goes into that, what? 32. 2 goes into that, what? 3 times. Does 3 go into 32? No, it doesn't. Alright, so what I have to do now, I'll tell you what, let's write it a little bit cleaner than that. Let's put 32 over 3 times the cube root of 3. Right with me on that? So now, I got to do a little trick here. We remember the trick, don't we? This is 3 to the first. What am I going to have to multiply it by? I don't just multiply it by itself, because it's not a square root. It's a cube root. So I multiply it by the cube root of 3 squared. Good. Because 3 to the first, if I'm multiplying together, 3 to the first times 3 to the second is 3 to the third. That's what I wanted. I wanted something to the third power, right? Because the cube root of 3 to the third comes out to just to be a 3. Okay? That's my whole purpose. Now, whatever, when I do that to the bottom, I also have to do that to the top. We're almost there. Almost. I can feel it. All right? So let's see what we got. We got what? 32 times the cube root of, let's just multiply that together. 3 squared is 9. All right, what about the bottom? Well, we got a 3, right, from this 3 right here. Now I'm going to multiply these two together. Cube root of 3, cube root of 3 squared is the same thing as cube root of 3 cubed. So that's another what? 3. Everybody see that? We're almost done. This is the last step. Just simplify those two. Just make that a 9. That's all you got to do. So it's 32 cube root of 9 over 9. Is that how I read off the answer? Wow, good thing I started at the top. I was gonna try to fit that into that little place down there, but yeah, I mean that was a few steps, but I mean I think the steps make sense. Every time we finish one step and you look at it, you're like, okay, that's the next thing I got to do. All right, take things a little bit at a time. Don't look at it as this whole thing. I can't believe I got to do that whole thing. How can I memorize how to do that whole thing? You shouldn't be memorizing. All right, you should be looking at it and just going step by step, looking at it and say, okay, what's the first thing I have to do? Don't look at the end result. Look at the first thing I have to do. Simplify those radicals. So I did that. What's the next thing I have to do? Find a common denominator. Boom, I did that. Find the numerators. I did that. Right? From here to here wasn't hard, was it? That was just adding some numbers together and then seeing if anything cancels out. And it did, so that wasn't that big of a deal. This was probably the hardest part of the whole thing. It might not even be the hardest part now, right, after you saw it, but it's kind of new, right? This is the new part right here, where you had to multiply by the cube root of 3 squared on top and bottom. And then once you did that, the rest was kind of cake, right? That was easy. The bottom was pretty easy, right? Just realizing that the cube root of 3 cubed is 3. Multiplying them together, boom. And there you go. So it is several steps. I would count from here to here as 1 step, here to here as 2 steps. I don't even know if I'd count that as a step. That would be 3 steps, right? Working that out and then simplifying maybe 3.5 steps. I'll give that one. Okay, so it really wasn't that much of a deal, even though it looks like a lot of writing and stuff. Got to practice them though, all right? You got to practice them. I've given you a couple worksheets already on this stuff, so you can, you know, I know there wasn't tons of problems like this. There was only one each, right, from both of those. But you can always go to the book, couldn't you? All right, if you wanted to. That's if you want to. It's a big if. You could go to the book, find some problems like this. Hopefully you can find some odd problems, and then you can check the back of the book. Look, if you can do some even problems, if you don't see a certain type of a problem that's an odd problem, do the even one and come in and check the next day with me, and I've got an answer book. It shows you all the answers, okay? You can do that kind of stuff, all right? So you have a lot of resources at your fingertips. You can go online and talk about, you know, radical problems, you know, simplifying radicals or something. And you'll find so much stuff you just won't be able to even know where to start. And they'll give you practice problems. Go to Khan Academy. He'll go through stuff, I'm sure, like this. There's all kinds of sites, not just Khan, but there's a whole bunch of other. I mean, people love to show off that they know math. They do, man. I mean, mathematicians, and I don't count myself as one of them. I'm just a teacher. I wouldn't consider myself a mathematician, but mathematicians love to show off, and they do. I think they're very prideful, just like a sports star is very prideful. I mean, we all are, and they love to show people that they can explain things and they can, you know, do problems and stuff like that. And so it's all over the place online, and you can find it. All right. We good with this? Are we good with section A? You're okay with A? That's no big deal? All right. Do you want to hang on to these or you want to turn them in? Got a quiz tomorrow over it, so. All right. So it's going to cover just section 1.7. So I guess, I think this is just all of 1.7, right? This A and B. So it's just basically going to be a quiz that's on these 2 worksheets. I forget how many questions. I'll have to look. I'll take a peek.
I mean, like,